Hi, Course 3 students. Today we are on Lesson 61, Sequences. You've worked with sequences before. You might have called them patterns, but they're the same thing. It's a ordered list of numbers that follow a certain pattern or rule. Here we have 4 numbers in a pattern, 3, 6, 9, 12. It's pretty simple to see that I'm just adding 3 to the previous term to get the next number in the pattern. That type of pattern, when I'm adding 3, as we see here in this pattern, we get our next 3 numbers of 15, 18, 21. That is called an arithmetic sequence, where I'm adding to the previous term, which creates a constant difference. Constant difference is a subtraction. Remember that difference is the answer of a subtraction problem. So I have this constant difference of 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3. I always have that constant difference of 3. So with an arithmetic sequence, I am adding, and I have a constant difference. And I can follow that sequence on and find additional numbers in the pattern. Another type of pattern is this one where I have 1, 3, 9, 27. I'm not adding 3 this time, I'm multiplying by 3. Not every pattern is going to have 3 in it, just the 2 that we're looking at today. But I'm multiplying by 3 each time to get my additional terms down the line. This is called a geometric sequence, where I'm multiplying. And when I have a geometric sequence, I have a constant ratio. Remember, connection between multiplication and division. So I have a constant ratio. 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is 3. That gives me that constant ratio of 3 each time. So arithmetic sequence, I'm adding, and a geometric sequence, I'm multiplying. It's important to remember those two things about those two sequences. We can take the numbers in our sequence, and they have a position and a value. And I can put them in a chart like this. The position is just the ordinal number. So there's no pattern to that row. It's just 1, 2, 3, 4, 5, 6, and so on. The pattern or sequence is here in your bottom row. It's the term. We can put it in this chart here because we're going to create a formula with it. Because maybe I don't want to find the next 3 terms, maybe I want to find the 20th term. And instead of having to find all of the numbers in between 5 and 20, I can just jump right to the 20th term using that formula. And that's the next thing we're going to look at. Once I have the numbers in my charts, I can also create a graph with them on a coordinate plane. And we'll look at doing those as well. But before we graph them, let's create our formula. Example 3, write the formula that describes this sequence. So we have our sequence here, 3, 6, 9, 12. I look here, and this is the one we were looking at before. I'm adding 3, so that's just the sequence. But that's not what we're using in our formula. When in our sequences, we're always looking to the next number, and I'm looking left and right. When we write our formula, we're looking at what am I doing with my n to get to my a? What am I doing to my term to get the position number to get the value? So I'm looking vertically to create the formula. Okay. So if I look here, I could say that I'm adding 2. 1 plus 2 is 3. But then I would have to repeat that formula on the next one. 2 plus 2 is not 4. So I know it's not adding 2. So another way to get from 1 to 3 is multiplying by 3. So 1 times 3 is 3. 2 times 3 is 6. So now I can see that this is working. And I'm multiplying times 3 to figure out that value. So now that I know my rule, I can create my formula. And the formula is going to look like this. I'm starting with what I'm reaching, my value. And we're writing it a little bit different today. A subset n is how we say that. Sub is below, like a submarine goes below the water. So the the n is below the a. So a subset n is how we say that. It's called a superscript. Or, I'm sorry, a subscript. A superscript is an exponent where it's above. A subscript is what we have here. What this means is we're looking for the value of the nth term. Whatever number I put in for n, I'm looking for that value because remember, a equals value. So if I would put in, like we were talking about before, I want the value of the 20th term. Then I put in my formula, and whatever number is here, I put in place of my n in my formula. So if my 20th term is what I'm looking for, I multiply 3 times 20, and obviously that is 60. So as we did before, we could find the pattern of multiplying by 3, and I could continue multiplying until I get to the 20th term. But with my formula now, I jumped right to the 20th term and found out it was 60. Let's look at one more formula. Here in example 4, here we have 1, 3, 9, 27. It's a little bit different. It does involve a constant ratio, as you see here in our chart. We got a constant ratio of 3, and there's something to do with the exponent. So here they tried a subset n equals 3 to the n using that exponent. Where 3 to the first is 3, and 3 to the second is 9, and 3 to the third is 27, which is correct in our chart here, but we're missing this first term, so we're not quite right. So this is the correct formula right here. 3 subset n equals 3, n minus 1. And notice that's in parentheses and it's an exponent. So what that means is I'm taking my n, whatever number, the position number I am, and I'm subtracting 1. That's the exponent. Okay, so they worked it out here where it's the first position, 1 minus 1 equals 0. 1 minus 1 equals 0. And obviously, 3 to the 0 power equals 1. Hey, that's my first value. Look at the next one. A subset 2, the second position would be 3, 2. This just copies over. 2 minus 1, because minus 1 is part of my formula. 3 to the first power is 3, and that's my second value. The third one, a subset 3. I copy my 3 because it's 3 minus 1, and that gives me 2. 3 squared is 9, and you can see that that pattern continues. So this is a little bit more of a complicated formula where I got a exponent, but I have to subtract first to figure out what that exponent is. But that's an example of some of these formulas that we will be working with. All right, let's take a look at our lesson notes. Down here at the bottom, we have 4 examples. I would like you to do number 1. There's 4 answers or 4 problems for that number 1. Describe the sequence as arithmetic, geometric, or neither. Remember, arithmetic is adding, geometric is multiplying, and neither might be a combination of the two, or might have an exponent type relationship, as we were looking at some of those other ones. Number 2 is another one I'd like you to do, and number 4. So please work through those problems on your note sheet, bring them to class, and we will check them over and move on with our assignment. Have a great day.